Hello there, Mr. Sutton here, bringing you the Algebra 2 5-3 Part 1 homework solutions on graphing radical functions. For this problem, we're trying to graph the h function, so I'm going to start by figuring out what type of transformation this is on the original radical x function. We have a plus 4 outside. That means this is going to be a translation of up 4. So my original parent table for square root of x, that's going to be 0, 0, 1, 1, and 4, 2. And for transforming this, it looks like there's nothing happening inside the function, so my x's are going to stay the same. For the y's, though, I have to add 4 to those to get this upward translation of 4. So my x's are still going to be 0, 1, and 4. And then for the y values, we've got 0 plus 4 is 4, 1 becomes 5, and 2 plus 4 is 6. Putting this together on a graph, we have 0, 4 right there, 1, 5, and 4, 6 is all the way up here. There we go. And we have an endpoint with these square roots. That's at 0, 0, or now 0, 4. So starting here, we're going to go through the rest of these off into the distance. To graph the g function, let's first figure out how this is transforming the square root function. The plus 1 inside means we are translating or shifting left 1. It's opposite of what you expect. And then the plus 8 outside means we're going up 8. So left 1, up 8. My original square root function parent table here, we've got 0, 0, 1, 1, and 4, 2. And then for the x's, when I do the new table for the g function, since we're going left 1, we have to do x minus 1. Up 8 means we're doing y plus 8. And let's apply these now. So 0 minus 1 is negative 1. 1 minus 1 is 0, and 4 minus 1 is 3. Let's add 8 to all the y values here. 0 becomes 8, 1 becomes 9, and 2 becomes 10. Putting that all together on a graph, and I'm going to just make sure I've got enough room up here to fit things. We've got negative 1, 8 right there, and that's going to be the endpoint of our square root function. 0, 9 is right there, and then we've got 3, 10 up here. So go through those, and that's our square root function now. For this function, we have a couple transformations of the square root function going on. The 1/5 out here is giving us a vertical shrink, and the minus 3 inside is translating us 3 units to the right. So right 3 and vertical shrink. So here's the original parent table here, 0, 0, 1, 1, and 4, 2 for the square root function. And for the x values, when I do my new rules for the g of x function, right 3 means we have to do x plus 3. And our vertical shrink out here means we're doing 1/5 times y. So adding 3 to all my x values, I've got 3, 1 becomes 4, and then 4 plus 3 is 7. For the 1/5 times y, 0 times 1/5 is still 0. 1 becomes 1/5, or 0.2 if you like. And then 2, a fifth of that, is going to be 0.4. Putting that all on a graph. So let's see here. I've got 0, 3 right there, or 3, 0 rather, right there. It's an x-intercept, not a y-intercept. 4, 0.2 is going to be like a fifth of the way up a grid line. And then 7, 0.4, that's 2/5 of the way. So very slow growing function. And then here is the completed function if I go through those points. To graph this function, let's write down the transformation first. The 2 outside is giving us a vertical stretch. The minus 1 inside gives us a shift 1 to the right. So vertical stretch, translation right 1. Our original table from the radical x function is just 0, 0, 1, 1, and 4, 2. Those are 3 helpful points to use. And then for the g of x table now, since we're going right 1, we have x plus 1 for that rule, and the vertical stretch outside makes us do 2 times y. So adding 1 to each of these values, we now have 1, 1 becomes 2, 4 becomes 5, and then we're going to multiply the y values by 2, so 0 is still 0, 1 becomes 2, and 2 times 2 is 4. Let's graph these points out. So we have 1, 0 right there, 2, 2, and 5, 4 is right up there. Our new endpoint is 1, 0 because that came from 0, 0. So starting right here, we're going through the rest of these points. On this problem, we have this 1/2 power. I'm going to start this problem by turning that 1/2 power into the square root function, because that's basically what that is. So this is really asking about the square root of 6x plus 3. Now to graph this, let's figure out what kind of transformations are going on versus the regular radical x function. The 6 inside being multiplied is giving us a horizontal shrink, and the plus 3 outside is translating us up by 3 units. So horizontal shrink and up 3. The original radical x function, that's again a good parent table for that would be 0, 0, 1, 1, and 4, 2. To do the f of x function, since I have this horizontal shrink going on, this times 6 here really means we're multiplying the x values by 1 over 6. And then the plus 3 outside means we're doing y plus 3. So 1/6 times my x values, we've got 0. 1 becomes 1 over 6, or 0.17 if you want. And then 4 becomes 4 over 6, or 2/3. Adding 3 to my y values, 0, 1, and 2 are now becoming 3, 4, and 5. 7 rather. Now that should be 5. There we go. Don't know where I got 7 from. Probably accidentally added the 3 to the 4. Anyway, it's 5. So, graphing all that out, we have 0, 3, 1/6, so this, eyeball it as best you can, 4, so pretty close to the y-axis. And then 2/3 is a little easier to do, 5. And then let's go through those points. For this next problem, we have a 4th root going on. Let's deal with the transformation first. We only have a negative outside the function, so that just gives us a vertical reflection, and that's the only change. So for the 4th root parent table, we've got 0, 0, 1, 1, and I'm going to go with 2 to the 4th, 2, so 16 and 2 is our 3rd point there. All right, so let's do the h table now. X is staying the same because there was no changes inside the function. For y, we're now going to do negative y. We're flipping everything vertically. So the x values are still 0, 1, and 16. For the y values, now we have 0, -1, and -2. Putting all that on a graph, I'm going to make my x grid lines go by 2's here so I can fit everything. So we've got 0, 0. We have 1, -1 down there. And we have 16, -2 right there. And we've just got an upside down sort of square root function going on.